Okay, guys, we are on our very last unit of the year. This is our statistics unit. So you can see here that I printed out the new packet. It's Unit 11, and that should be attached on EduFlow. You can either print it out or you can take the notes directly in your notebooks. And we are in Packet 1, okay? Let's flip. You're going to see some, oh, sorry, I only printed out the pages I needed. On pages 2 through 4, you're going to see some nice reviews, some graphs. I think it's really important that you go back and look at those. But I am going to start on page 5. Okay? Below is the data for 9 students surveyed on how many pairs of shoes they own. Use the following data to answer questions 1 through 3. What is the mean? Well, I hope the mean that you know is it's kind of like the average, right? So we're going to take the sum of our numbers. Okay, so the sum of our numbers, and we're going to divide it by the number. So that's going to be, let's see, let's add these up. Okay, we're going to take, you add them all up, 2 plus 2 plus 4 plus 6 plus 7 plus 7 plus 7 plus 9 plus 10. Oopsie. Plus 9 plus 10, and you're going to get 54. You're going to divide it however many numbers there are. There are 1, 2, 3, 4, 5, 6, 7, 8, 9. 54 divided by 9 is 6. Okay, so we're going to say mean, and you always put mean. You put this mean bar over it. Okay, so the mean is 6. Okay, what is the median? The median, I hope you know, is in the middle. Okay, so that is when you put them in ascending order, and then you look at the middle. So what I do is I just literally cross them off as I go. Okay, so you got this. They're already in ascending order. You're looking for that middle value. Looks like it's 7. Okay, so 7. 7 is the middle or the median. And then we're looking for the mode of the data, and that's the one that occurs most often. Okay, and if you look at that data, looks like 7 occurs the most often. Okay, so that's how we do that. We are going to go ahead and we are going to, we can't do that because we're not in class together. So we will go ahead and we will flip to page 6. A lot of this is going to be review for you. Okay, measures of shape and center. Measures of central tendency or the center of the data. The mean, and we always, like I said, a little bar over it. We call it the X bar. Okay, and that's what I referred to as the average. Okay, and you're going to add up all the values, okay, of the, we'll say data points, and we divide by the number of data points. Okay, so that's what you would call your mean. Okay, then we have our median, which is the number in the middle when data is in ascending order. Okay, it's really important that you put them in ascending order, meaning from smallest to biggest. And this important note that I want you to write down is if there is an even number of even number of numbers, we can say, then the median is the average of the two middle numbers. A lot of writing here. Sorry, guys. Middle numbers. Okay. So you basically I go from each side, eliminating. I get to the middle two, and then I take the average of those two numbers. Okay. And then let's write in a different pen so you can actually see this. The mode is just the most often. All my pens are running out on me. Is the most often. Okay. Good. So that's kind of review. Example 1. Find the mean, median, and mode of the grades received on the last algebra test. Okay. I nicely put them in ascending order for you. So we're going to find the mean first, which means I'm going to add them all up. So I'm going to add them. We've got 80 plus 85 plus 90 plus 100 plus 100. And we would divide that by 5. Let's see what we get. 80 plus 85 plus 90 plus 100 plus 100 and divide that by 5. Whoopsie. We get 91. Okay, so 91 is the median. The mean, sorry, 91 is the mean. The median is going to be that middle value. So I just kind of go through. Oh, there's an odd number, so it's going to be 90. And the mode is the most often or frequent. Looks like we have two 100s. So 100 is the mode, okay? And which measure of central tendency is the best representation of how many students performed on this test? Well, it's not going to be the mode. It's not the mode, okay? It just really tells us very little. Tells us very little. And the good thing here on these is that the mean and median are close together. So mean and median close together. So really either would be a good representation. Either would be good rep. Okay? One visual way to represent data, you could say a graph or plot of frequencies. That's the important word here, frequencies of data points using dots or X's, okay? So we didn't get to do the number of children in your family because we're not all together, but assuming that, some of you have one in your family, some have two, some have 3, 4, 5, etc. Okay? If 2 of you had one child in your family, we could do 2 dots. And let's say that there were 9 of you that had 2 children in your family, you could do 1, 2, 3, 4, 5, 6, 7, 8, 9, something like that, etc., etc. Okay, if there were 7 of you, 1, 2, 3, 4, 5, 6, 7 that had 3 children, and so on and so forth. Okay, and that's how you would actually write the frequency of data points, by showing it in a graph like that. Okay, let's go ahead and let's move on to page 7. Okay. These are a little bit hard to see, and this is the info that might be new for some of you. Okay, visual data in the form of dot plots, shape of the data. Okay, so what I do when I'm looking at these, I just kind of do something like this, just so I can visualize it. I'd go like this, okay? And this one is what we're going to say is skewed right, okay? And when it's skewed right, basically what that means is that with right skewed distribution, most data falls to the right of the graph's peak. Okay, it skews in such a way that its right side, or the tail, is longer than the left. So if you think of that as a little tail, it's longer than the left-hand side. Okay, and this is what's really important as your takeaway for this, is that when it's skewed right, the mean is greater than the median and mode. Okay, on this one, you can see, kind of go like this. We can see that the tail is to the left, so it's skewed left, okay? And this is important again. This is when the mean is less than the median and mode, okay? This one looks approximately symmetrical. Approximately symmetrical. Okay, which we sometimes hear as someone say like a normal distribution. Okay, and here the mean is going to equal the median, is going to equal the mode, or it's going to be pretty darn close. Okay, and then here you can see we kind of have a up and then up, kind of 2 little humps or peaks there. That's what we call bimodal. Okay. And that's the 2 modes. Bimodal or 2 modes. The mean will be between 2 modes. Okay. And the median will also usually be, okay? And median also, oopsie, I can't spell, also will be, okay? But the important thing to see is that you have these modes, right? And then you're gonna know that the mean, and more often than not, the median is gonna fall in between, okay? Outlier, I'm gonna write it down here so we can actually read it, is a data value that is significantly greater or less than the other values in the set, than the other values in the set, okay? So that's what we talk about when we're talking about outliers, okay? Let's go ahead and let's, no, I don't want to look at 8 right now. Let's skip to page 9. Okay, we're on page 9. And I just want to kind of go over some of these so you can see them. And I want you to get practice on the skewing, okay? Here we can see tails to the right, skews right, which means the mean is greater than median and mode. Okay, this one, I hope you see that that's approximately symmetrical. Symmetrical, which you should remember from the previous page that I said that means the mean equals the median equals the mode. Okay, and then this one, you can see that tail is to the left, so we're skewed left. Okay, and here, where it was right, the mean's greater. When it's skewed left, it means the mean is less than the median and mode. Okay, let's see, tails over here, we're going to skew left, mean less than median, less than mode. Here, you can see the tail, we're skewed right. And if you see in that picture, look at that. The mean, which is down here, is greater than the median and mode. And it's all because of the outliers, okay? So the mean is greater than the median and mode, okay? Same thing, you can see this, we're skewed left. Mean, less than median and mode. You guys are getting these down. And this one, I'm gonna say that's approximately symmetrical, okay? It's not exact, but it's pretty close. That means all of them are going to be approximately, I use that approximate sign because as you can tell, it's not exactly symmetrical, but mean, let's see, median, approximately mode, okay? So they're all approximately the same. Okay, moving right along, we are going to go to page 10. And we're in the home stretch here. We're almost done, okay? Let's look at this average number of hours spent in the gym each week, okay? So here are the numbers out. So one person spends 2 hours, 1, 2, 3 people spend 5 hours, et cetera, and this is in a week's time, okay? As you can see, if you look at this, oh, this is definitely a possible outlier. Look at that. Didn't even notice at first. Outlier. I would say that this is bimodal, okay? And skewed right, slightly, right? And that's because of that outlier over there, okay? Okay, so we know what that is. Here, what do we see here? This looks like the data. Well, that looks like it's skewed right for sure, right? Skewed right. Okay. And draw an example of each. So here, we're going to have our symmetrical. Skewed right is going to look like something like this. Okay. Skewed right or skewed left. I'm not the best artist, but we're going to do something like this. And then my bimodal is going to be 2 of those little humps or those modes that, right? And we fall in between those modes. Okay. Let's do one where we actually have to draw our dot plot. Okay. So here, let's look at number 2. Sorry, we're on page 11. Okay. A random sample of 25 high school students was surveyed. The responses to 6 questions are provided below. Some students chose not to answer every question for each data set. Okay, create a dot plot. Okay, so I'm going to go ahead and I have my little scale written here. it looks like we're all the way from 0 on up to 36. So I'm going to go 0, 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to go all the way down to show the distance that, there's an outlier here. And that's 36 over here. Okay. And you can use dots or X's. I'm going to use X's. I tend to use X's because I think they're easier to see. Okay. So let's count how many were at 0. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, it looks like. Okay. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I'm just going to cross those off so I know I got them. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, got them all. I can see we have 0.5 somewhere. Look at that one right there. Okay, so I'm just going to put a little X in the middle here to represent 0.5. I crossed that one off. We got some 1s. Looks like 2 of them. So I'm going to do a couple of X's there. Okay, now we're on to 3. I see no 3s. We're on to 4. I see no 4s. We're on to 5. I see 1. So I'll put my little X. Okay, let's see. No, 1, 6. Cross that one off. I always cross them off so I make sure that I actually counted them. Which I didn't do the 2s. I skipped over those. Let's look at that. 1, 2, 3, 4, 5, 6, it looks like. 1, 2, 3, 4, 5, 6. What else do we have there? We have an 8, it looks like. Is that an 8? Yep, right here. We have an 8. And then we have that 36 way down here. Okay? So you can kind of see our data here. Looks like, okay, so I would say in this case, the shape is that it looks like the tail's to the right, so it's skewed right. Okay? I would probably add in my description that there's a possible outlier. I don't even know how possible it is at 36. Okay, and then if you wanted to calculate the mean, the median, and the mode, well, the one that's the most frequent is obviously 0. So that's my mode. My median is my middle value. So I just literally, let's see, there were 1, 2, 3. I would literally go through each one to find the middle value. Oh, is it going to be 0.5? You actually, in a perfect world, what you would do is you would reorder these. You'd literally go 0, 0, 0. You'd list them all. There was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 6, 7. And then there was a 0.5. There was 2 1s. There were 1, 2, 3, 4, 5, 6 2s. There was a 5. There was a 6. There was an 8. And there was a 36. And then you literally go one by one across them off to find the middle value. You can see that I'm doing that here. It's tedious, I know, but that's literally how you're going to find it. I think that when I counted these, it looks like, yep, it's 0.5. So that's my middle value or my median. Now I'm going to add these all up and I'm going to divide by however many there are. And I'm just going to tell you when I did it because I already did earlier. You get 2.78. Okay, that is your mean. Okay, so that's just kind of a rundown of how you're going to put together one of those dot plots and actually calculate the mean and median, okay, and mode. And I think that looks like pretty much we're good for the day. The only other thing that I want to comment to you on is that on page, if I can find it here, 13, it goes through a nice little summary, okay, of what kind of all the data points mean. Okay, sorry, my camera's, there we go. You can actually see it now. And this is page 13, okay? I'm just gonna write this here for you real quick. I was gonna have you do this for homework, but I think I'm just gonna run through these real quickly for you. 1, when data is skewed right, how does the mean compare to the median? Okay, we're going to say the mean is greater and I think this page is so super important that you know, okay? The outlier to the right influence the mean, okay? So that's what I would say with respect to the first question. What does the second say? When data is skewed left, how does the mean compare to the median? Okay, well, the mean is now going to be less than the median, okay? And again, the outlier influences the mean, okay? 3, when the data is approximately symmetrical, how does the mean compare to the median? Mean and median are very close, okay? If not the same. If we're on, let's see, what does 4 say? When data is bimodal, how does the mean compare to the median? Well, that's when the mean is between, right? Let's just do it that way. The mean is between the two modals. And I'd say, and the median is closer to the larger modal, which only makes sense. Larger modal. Okay? How does the outlier, let's make sure you can actually see this. 5, how does an outlier change the mean? Well, the outlier causes the mean to move closer to the outlier values, right? It only makes sense. You have a bunch of values and you're trying to find the average, and then you have one that's far off on either side. It's going to cause that mean to move closer to that outlier value, okay? And finally, when is the median a better measure of center? I'd say this is a pretty important question. When data is skewed left, right, or has outliers, okay? So in that case, the median is actually going to be a better measure of center than the median. Typically, we see the median, but if the data is skewed left or right or has these big outliers, your median is going to be better. Okay, and I think that is more than enough for today.